Alright, ladies and gentlemen, today we're going to look at literal equations. A literal equation is a single equation, but it's got multiple variables. And what we're going to do with that equation is we are going to solve for one of the variables. And we're going to solve for it in terms of the other, meaning that our answer is not just going to be a single number necessarily. We could solve for x and we could have a y in it, a y and a z in it, or multiple other variables in it. This skill is really, really useful, especially in the sciences. In the sciences, you tend to have formulas that you use from time to time, and what this allows you to do is, if let's say you'd rather have you've got an equation that's got temperature, pressure, and volume in it. If in the form it's given to you, it's temperature equals something. Maybe you don't want it to be temperature equals something. Maybe you want it to be pressure equals something. What this allows you to do is manipulate that equation and solve for any of the variables. Okay, so here's what we're looking at. A good example might be something like this: 3x plus 4y equals 12. Let's say that we're solving for x, okay? So I'm going to make the x red so we know that we're solving for that one. The thing that you have to keep in mind is that there's a difference between getting rid of a term versus getting rid of a coefficient, okay? So if we're trying to get x by itself, we need to move the 4y and the 3. Typically, when we've gotten rid of stuff with variables, it's always involved division, but we are trying to get rid of this whole term over here. 4y, that's a term. It's something that's being added or subtracted. So to move the whole thing over to the other side, we need to subtract 4y. We shouldn't actually be doing any division there. Okay, and again, so one of the easiest ways to think about, well, how do I know that I'm supposed to do that? Think if you replaced y with an actual number, like 3. You'd have 4 times 3, which is 12, and you'd subtract 12 from both sides. If you had a 5 there, that would become a 20, and you'd subtract 20. Either way, you're going to be subtracting it from both sides. We don't know what the y is, but that doesn't mean we can't subtract it from the other side. So now we've got 3x equals 12 minus 4y. Divide everything by 3. And since we're dividing both sides by 3, take a look at what we have on the other side there. Doesn't that look an awful lot like the distributive property with division? That's because it is. So we do 12 over 3, which is 4, and then 4 over 3, which will just leave 4/3 y. So the solving process really isn't a whole lot different than it is with with a normal equation where you've got a number as an answer, but you just have to be a little bit more careful, and you're probably going to have to, if you divide or multiply by something on both sides, you're going to have to use a distributive property, okay, which is kind of why we look at it this unit. So try B on your own, pause, and then come back. All right, welcome back. First thing you're going to want to do is subtract 5y. You're going to want to get that over to the other side because we need to get rid of that whole thing. And that's a term, so we're going to subtract it to the other side. Then we need to get rid of the 3. Since it's 3 times c, we'll divide by 3. We'll use the distributive property, and we'll get 4 minus 5/3 y. Okay, C is a little bit trickier, okay? You probably learned how to solve proportions last year. In fact, I know you did. And you may have learned how to do this in a couple different ways. I'm going to show you my way. If you have a different way, that's definitely okay. What I learned is that if you want to get rid of 2 fractions at the same time, what you can do is you can change this from a division problem, which is what it is now, into a multiplication problem by multiplying your diagonals together. You're taking what's called your cross products and setting those equal to each other. So 3c times r equals 2x times y. You can do that anytime you have a fraction equal to a fraction. As a side note, okay, this is just a side note. Like if we had something like 1/2 equals x over 4, you know that that x is 2, because 2/4 is 1/2. But let's just look. If we do cross products, we get 2 times x equals 1 times 4, which is 4. If we divide by 2, we get our 2. So that works, okay? So looking over here, now if we want to solve for x, we got to get rid of the 2 and the y. Both of them are being multiplied, so we'll divide by 2y. And we get x equals this. That's it. There's no simplifying we can do there. Can't simplify 3 over 2, and none of the variables cancel out either. So that's all we get there. That's one of the trickier examples you'll see, but it's a good one to know because a lot of formulas involve fractions, and again, that's where this can be really useful. That's it for this one. So again, the solving is very much like a normal equation, with the biggest differences being you're not always going to be able to combine like terms. When you subtract a 4y from both sides, you can't always have something to combine that with, and your answers will have variables in them. That's it for this one.